We've been talking about how to normalize database tables in a manner to bring them to what is called first normal form. But is there more we can do? Actually, yes. Thanks for joining me again today as we consider the next level of database normalization with second normal form. Last time we covered first normal form. Today, we're moving on to second normal form, a step that helps us reduce redundancy and improve data consistency even further. So, second normal form is based on the concept of a fully functional dependency. This means that a table is in second normal form if it's already in first normal form, and every non-key attribute depends on the entire primary key, not just part of it. If any column depends only on part of a composite key, that is called a partial dependency, and it violates second normal form. This phrase, partial dependency, may seem confusing, so for a moment more, let's talk further about what this means. Let's say a primary key is made up of two columns. If a non-key attribute depends on only one of those columns rather than the whole combination, that's called a partial dependency. Think of it this way. If your primary key is column A and B, then all non-key attributes should depend on both column A and B. If a column depends only on A or only on B, then the table is not in second normal form. Let's consider the following staff branch table. We have a staff number, staff name, and a branch number column. So here, the composite key is staff number and staff name. But notice that the table also includes the branch number. Branch number actually only depends on the staff number key and not on the staff name column. That means that branch number is a partial dependency. The solution is to split the table. So we would take the staff table and have a staff number and a staff name column, and we would have a branch table with a staff number and a branch number column. Now, every non-key attribute depends on the entire key. Let's consider another common scenario with courses and fees. Suppose we have a table called student course, and it is comprised of three columns: student number, and course fee. The composite key here is the student number and the course number, but the course fee depends only on the course number and not on the student number. This table again demonstrates a partial dependency, with the course fee column being the oddball out, so to speak. The way we would fix this and thereby move to second normal form is to decompose the table into two. We would need to modify the student course table by extracting the partial dependency to a newly created course table, as you can see now. Looking at the student course table and the course table, we have a course fee that depends now only on the course number, a student course that only tracks which student is enrolled in which course, and the net gain is no more partial dependency. Awesome, right? So I can hear the gears turning in some of your minds right now, because you might be asking, why does removing partial dependency even matter? Well, the reason for this in eliminating a partial dependency is, number one, we reduce redundancy, and that's huge. That's important. And second, we prevent update anomalies because we've reduced redundancy. We don't have data stored in other columns that we have to keep track of and update. And this simply makes inserts and deletes as well more consistent. We need our database tables to be simple, easy to maintain, and easy to update and or delete data as necessary. If our database cannot be consistent, meaning the data stored does not agree, that's a huge problem. Now, second normal form is not the end of the story because it doesn't handle transitive dependencies. That's where third normal form comes in, which we'll cover in the next video. So to summarize, first normal form removes repeating columns and groups. Second normal form removes partial dependencies. Together, they make our database more reliable. In the next video, as I mentioned, we'll look at third normal form and how this takes it further by addressing what is called transitive dependencies, and thus allowing our database tables to achieve a full normalized state. Hey, you made it to the end. Do me a favor and like and subscribe. And leave me a comment. If you learned something new today, I'd love to hear from you. That's it for now. I'll see you in the next video as we look at third normal forms. Take care.